Good morning. The topics we'll be covering as of now is Introduction to Cassandra, RDBMS design in Cassandra, and how to create database and to load their schemes. So, coming to the introduction and what Cassandra is and what it is used on. So, this Apache Cassandra is highly scalable, has high performance, distributed NoSQL database, and this Cassandra is designed to handle huge amount of data across many commodity servers and also to provide high availability without a single point of failure. So this Cassandra has a distributed architecture which is capable to handle a huge amount of data, and the data is placed on different machines with more than one replication factor to attain a high availability without a single point of failure. And this Cassandra is a new SQL database. And no, as you've seen before the sentence, that Cassandra is a NoSQL database. NoSQL database means it is non-relational database. That is, it is also called not only SQL. And it is a database that provides a mechanism to store and retrieve data other than the tabular relations used in relational databases. So these databases are schema-free, support easy replication, have simple API, eventually consistent, and can handle huge amounts of data. So here, since Cassandra is a NoSQL database, the primary objective of a NoSQL database is to have simplicity of design, horizontal scaling, and finer control over availability. And we'll discuss on some of the important points that are required or to remember while working with Cassandra. That is, Cassandra is a column-oriented database. It is scalable, consistent, and fault-tolerant. And Cassandra's distribution design is based on Amazon's Dynamo and its data model on Google's Big Table. And it is created at Facebook, which is totally different from relational database management systems. And this Cassandra follows a Dynamo-style replication model with no single point of failure, but adds a more powerful column family data model. And Cassandra is being used by some of the biggest companies like Facebook, Twitter, Cisco, Rackspace, eBay, Twitter, Netflix, and more. And we look into the architecture of Cassandra. So this Cassandra was designed to handle big data workloads across multiple nodes without a single point of failure. It has a peer-to-peer distributed system across its nodes, and data is distributed among all the nodes in a cluster. And here what happens in Cassandra is that each node is independent and at the same time interconnected to other nodes. So all the nodes in a cluster play the same role. So every node in a cluster can accept read and write requests, regardless of where the data is actually located in the cluster. And in the case of failure of one node, or any one of the read or write requests can be served from the other nodes in the network. So this Cassandra query language is used to access Cassandra through its nodes. So SQL treats the database, that is key space, as the container of tables, and programmers use a prompt to work with SQL or to separate application language drivers. So the client can approach any of the nodes for their read-write operations. That node coordinator plays a proxy between the client and the nodes holding the data. So we look into the write operations. So every write activity of nodes is captured by the commit logs written in the nodes. Later, what happens is that this data will be captured and stored in the memory table. And whenever the memory table is full, data will be written into the SS table data file. And all writes are automatically partitioned and replicated throughout the cluster. And Cassandra periodically consolidates the SST tables discarding the unnecessary data. And this is the representation of the write operation. So as you can see, the write data is here. The commit log happens, which is then taken over to the memory table. We have a memory disk, which is connected over with a flush and also with the index and SS table. Next one is the read operations. So in read operations, Cassandra gets values from the memory table and checks the Bloom filter to find the appropriate SST table which contains the required data. So there are three types of read requests that is sent to replicas by coordinators. The first one is direct request. The second one is digest request. The third one is read repair request. So what happens with this read operation? Okay, a representation is given and the coordinator sends direct request to one of the replicas. After that, the coordinator sends the digest request to the number of replicas specified by the consistency level and checks if the return data is an updated data. After which, the coordinator sends digest request to all the remaining replicas. If any node gives out of date value, a background read repair request will update the data. This process is called read repair mechanism. And we look into the components of Cassandra. So Cassandra has components as in they are named as nodes, data centers, clusters, commit logs, memory table, SS table, and Bloom filter. So a node. So what happens here? A Cassandra node is a place where data is stored. And what happens in a data center is a collection of related nodes. And in a cluster is a component which contains one or more data centers. And a commit log. In Cassandra, the commit log is a crash recovery mechanism. Every write operation is written to the commit log. And memory table, a memory table is a memory resident data structure. After commit log, the data will be written to the memory table. Sometimes for a single column family, there will be multiple memory tables. And in a SS table, it is a disk file to which the data is flushed from the memory table when its contents reach a threshold value. And for a Bloom filter, these are nothing but quick non-deterministic algorithms for testing whether an element is a member of a set. And so this is a special kind of cache. So these Bloom filters are accessed after every query. So we have, this is the difference between Cassandra and RDBMS. Okay. So Cassandra is used to deal with unstructured data, whereas RDBMS is used to deal with structured data. And this Cassandra has flexible schema, but RDMS has a fixed schema. And in Cassandra, a table is a list of nested key value pairs, that is row, column key, and column value. But in RDBMS, a table is an array of arrays, that is row and column. And in Cassandra, key space is the outermost container which contains data corresponding to an application. But in RDBMS, database is the outermost container which contains data corresponding to an application. So in Cassandra, tables or column families are the entity of a key space. In RDBMS, tables are the entities of a database. In Cassandra, what happens is row is a unit of replication, but in RDBMS, row is an individual row. Here in a Cassandra, a column is taken as a unit of storage. In RDBMS, a column would represent the attributes of a relation. In Cassandra, the relationships are represented using collections. In RDBMS, there are concepts of foreign keys, joins, and etc. So now we'll look into how to create database in Cassandra. So first they're going to log in to the database and then create a database. And this is the given command for that. So creating a key space in Cassandra is the same as creating a database in SQL. So the example is given, that is to check all the key spaces which are already created. Then you can run the following SQL query with the given commands. And the other command is to check the app data key spaces, which is created or not. And this is the output given for the given example. Third one, here the command on how to describing the key space is given here. Okay, so now we'll look into how to load the schema, that is the Cassandra table index. We have 4 points, that is how to create table, alter table, drop table, and to truncate table. So we'll be looking that in the next part. So I'll give a revision or a look through of what we have seen. We have seen about Cassandra, what Cassandra is, and we have seen an introduction. We have seen that it is a NoSQL database. We have seen its primary objectives, the points that should be remembered about its architecture, about the write and read operations, and we've also read about the components of Cassandra and how the difference between Cassandra and the RDBM is. And we've also seen how to create databases, how to create key space. We've seen certain examples, and we'll be looking forth with the loading schema in the next session. Thank you.